Hey, I'm Brian, and this is Ship It Weekly by Tellers Tech. It's reInvent week, which means AWS has fire hosed us with announcements. Instead of trying to read you the keynote, I want to pull out the stuff that actually matters if you run platforms, Kubernetes, or CI in the real world. So here's the plan for this episode. First, we're going to hit the AWS updates that I think are worth caring about if you own networking, clusters, data, or security. That includes things like regional NAT gateways, Route 53 global resolver, EKS capabilities, ECS express mode, S3 vectors, 50 terabyte S3 objects, Aurora dynamic masking, CodeCommit coming back from the dead, and IAM Policy Autopilot. Then we will step outside AWS. We will talk about Google's 130,000 node GKE cluster and what lessons from that actually apply if you are just trying to keep your 20 node prod cluster sane. After that, we will get into a piece called It's Time to Kill Staging and talk about what testing in production should and should not mean. In the lightning round, we will hit a Terraform MCP server that lets AI tools speak your Terraform modules, a neat EC2 instance ranking tool for right sizing, and an SRE story from Airbnb on adaptive traffic management. And then we will close with a human story about the fate of small open source and what that means for all the tiny projects your platform probably depends on. All right. Let's start with AWS. I am not going to cover every AI chip and marketing bullet from reInvent. I want to split this into four buckets: networking, compute and platform, data, and dev tools plus security. Let's start with networking because that is where a lot of the quiet pain usually lives. AWS announced regional availability mode for NAT Gateway. Instead of spinning up one NAT per AZ and wiring custom routes to each one, you can now create a single regional NAT that automatically spans all the AZs in your VPC and scales with where your workloads actually are. Practically, that means simpler route tables, fewer moving parts to keep in sync, and a more straightforward story when you talk about high availability for private subnets. You still need to think about cost and IP space, but the model is more one service per region rather than a little cluster of pets per AZ. On the DNS side, AWS introduced Route 53 Global Resolver. This is an Anycast DNS service that sits in front of both your public and private DNS, and it adds some smarts on top of it. It can filter queries to suspicious domains and uses algorithmic analysis to detect things like DNS tunneling and weird domain generation patterns, not just is this domain on a known bad list. There is also an accelerated recovery pattern in the docs for managing public DNS records faster and more safely. The recent US East 1 DNS pain is still fresh in a lot of people's minds. So, this is a good moment to ask yourself, if Route 53 has a bad day again, how fast can we move? And do we actually know where all of our critical DNS records live? So, if you own networking, here's how I would use these. First, look at where you are today with NAT. If you have a mix of per AZ NATs, some services still hairpinning through old instances, and a bunch of legacy route table entries, the regional mode might be a nice forcing function to clean that up. Use this as a chance to revisit how you allocate IPs and whether you can make IP, AM, and prefix lists do more work for you instead of hand curated CIDR spreadsheets. Second, treat Global Resolver as part of your threat model, not just a neat new service. If you have any compliance or data exfiltration concerns, ask how do we want DNS to behave for protected environments, and what logs do we need out of this to actually detect weird behavior. All right, networking rant over. Let's talk compute and platform stuff. On the container side, AWS launched Amazon ECS Express Mode. This is basically an easy button for ECS. You point it at a container image and it wires up an ECS service, cluster, application load balancer, Route 53 records, auto scaling, the usual plumbing with production ready defaults. You still have access to all of the underlying resources if you want to tweak them, but the entry path for a new service is much simpler. On the Kubernetes side, Amazon EKS capabilities went GA. Think of this as a fully managed bundle of platform features on top of EKS. It gives you Kubernetes native components for workload deployment, cloud resource management, and resource composition. The idea is AWS runs and patches a bunch of the core platform bits, and you interact with it using familiar Kubernetes APIs. The story here is pretty clear. AWS is trying to give you paved paths for app teams. If you are a smaller shop or you do not have the people to build your own golden path, ECS Express Mode and EKS capabilities are an attractive let AWS worry about more of the platform option. If you already have a strong platform story, these are still worth watching as a reference point for what batteries included looks like. Layered on top of that, we have Lambda durability functions. These let you write long running, stateful workflows directly as Lambda functions. They can checkpoint progress, pause for up to a year, resume after failures, and you do not have to bolt on your own state machine or air handling engine. That overlaps a bit with what folks use step functions or DIY orchestrators for today. I would not rip anything out just because durability functions is shiny, but if you were about to build a workflow system where functions need to wait on AI agents or external callbacks, I would at least prototype it this way and see if it simplifies your life. Now let's talk data and storage. S3 vectors is now generally available with scale bumping up to billions of vectors per index and trillions per bucket. It's the first time one of the big clouds has said, yeah, object storage can natively store and query vectors rather than forcing you into a separate vector database. The marketing line is up to 90% lower cost compared to specialized vector stores and tighter integration with Bedrock knowledge bases and OpenSearch. This is a pretty big deal if you are doing RAG or semantic search. You no longer have to manage a completely separate database just for embeddings. You can treat vectors as another dimension of your S3 data lake. There are still plenty of reasons to use a dedicated vector store for certain use cases, but for a lot of internal tooling, this is going to be good enough and way easier to operate. S3 also quietly increased the maximum object size from 5 terabytes to 50 terabytes. That changes how you think about backups, big media, and AI training data. The days of having to shard every giant file into dozens of pieces just to fit it into S3 limits are mostly gone now. On the database side, Aurora Postgres picked up dynamic data masking using the PG column mask extension. You can define policies at the column level, so certain roles see full values, others see masked values, and so on, enforced in the database itself. That is interesting if you have BI users, contractors, or internal tools that should see some shape of the data, but not raw PII. It also gives you another tool for compliance stories where keeping masking close to the data is a plus. Just remember, masking is not encryption, and it does not replace good role design or auditing. Finally, dev tools and security. AWS officially walked back the "we are de-emphasizing CodeCommit" thing. CodeCommit is back to full general availability, with AWS saying clearly that customers still want a fully managed Git service that lives inside their AWS estate. If you are in a heavily regulated environment, or you just like having repos inside the same blast radius as everything else, that is probably a relief. It also raises some awkward questions for teams that did a big migration off of CodeCommit after the original deprecation plan. There is a meta lesson here about how much you want to depend on any vendor's "this service is here forever" statement. And then there is IAM Policy Autopilot. This is a new open source MCP server that reads your application code and helps generate IAM policies that match what you are actually doing, instead of star everything and hope. It is designed to plug into AI coding tools so they can propose least privilege policies as part of your workflow. On one hand, this is fantastic. Writing good IAM is tedious, and anything that helps teams stop shipping wildly overly permissive policies is welcome. On the other hand, this is one of those great power, great responsibility things. I would absolutely run its output through human review and test, and I would be very careful about letting a model both propose and apply policies without a person in the loop. So, if you zoom out, what are the big AWS themes for platform folks this year? Networking and DNS get simpler and a bit smarter. Containers and Kubernetes get more paved roads. Data and AI workloads move closer to S3. Dev tools get more tightly integrated with IAM and AI. The work for you is deciding whether you want to lean in and let AWS carry more of the platform, and where you still want to keep your own opinionated stack. There's still more reinvent to go, so if anything huge drops after this recording, we'll pick it up in a future episode. All right, let's step out of Las Vegas and switch gears and talk about Google for a minute. Google published a blog about how they built a 130,000 node GKE cluster. This is experimental, not a new default limit, but it is still a wild number. The officially supported limit today is 65,000 nodes per cluster, so they basically doubled that for this project. The post talks about demand for massive AI and batch workloads. Think training or serving large models, very large scale simulations, things where packing as much work as possible into a single control plane has operational benefits. They had to do a bunch of architectural work to make this even remotely practical. Things like sharding control plane traffic and carefully tuning API server scaling so you are not just DDoSing your own Kubernetes API. Being very deliberate about how many objects live in etcd since you are easily into the millions of pods and other resources. Using job-oriented tooling like Queue to manage scheduling and fairness, so one noisy job does not starve everything else. Here's the thing though. Most of us are never going to run a 130,000 node cluster, and that is fine. The real lessons that I think are useful at a normal scale are control plane capacity is a thing you should care about. Even at 100 nodes, you can run into API throttling or controller backlogs during deploys or incident storms. Seeing Google talk about their control plane SLOs at this scale is a nice reminder that we should probably have some for our smaller clusters too. Job and workload management matters. Whether you have 5 jobs or 5,000, being explicit about priorities, quotas, and fairness is the difference between prod is fine during big experiments and someone kicked off a batch job and our customer traffic died. One cluster is not always better. The temptation with fancy scale numbers is maybe we should consolidate everything into one giant cluster. For most orgs, blast radius, compliance, and team boundaries are better served by multiple smaller clusters, even if that means a bit more overhead in the tooling. So my recommendation here is not go chase 130,000 nodes, it is steal the thinking. Read the post, look at how they reason about control plane scaling and scheduling, and then ask what the equivalent version of that would look like at your scale. All right, let's talk about staging environments. There is a new Stack article making the rounds called It's Time to Kill Staging, the case for testing in production. The short version is that staging environments are slow, expensive, and often lie to you, and more teams should lean into testing directly in production with the right safety rails. I have mixed feelings, which probably means the piece is doing its job. On the one hand, a lot of us have worked in places where staging is a bottleneck. 50 developers all merging into a shared staging cluster that does not really look like prod, then sitting in a queue waiting for a staging sign off that is mostly vibes. When that staging environment inevitably diverges from reality, you waste time debugging issues that would never happen in prod, and you miss issues that only show up under real traffic patterns. On the other hand, test in production without guardrails is just break production. I think the healthy middle ground looks like this. You treat staging as limited and cheap, not sacred. Use it for fast feedback on basic integration, maybe some performance smoke tests, but do not pretend it is a perfect mirror. You keep it simple enough that it is not its own full-time job to maintain. Then you build serious safety mechanisms into production. feature flags so you can roll changes out to 1% of traffic, or only to internal users, or only to specific regions. Progressive delivery so you can ramp traffic up and down based on real SLOs, not just it seems fine. Shadow traffic or replay so you can feed realistic requests into new versions without exposing users yet. Good observability and alerting so you know if the experiment is hurting real people. The article's core point is good. The only environment that exactly behaves like production is production. So if you want to be confident, you need to be able to experiment there. Just do it intentionally. So if you are listening to this and you own a platform, here is a question to take back. If someone on your team said, "We want to turn off staging in 6 months," what would you need in place in production to feel safe? List those things. That is probably your roadmap, whether or not you actually kill staging. All right, let's hit a lightning round. First quick one, Zachary Lober wrote a Terraform custom module MCP server and released a project called Terraform Ingest. It is a CLI and MCP server that crawls your Terraform module repo, summarizes them, and exposes that to AI tools so they can understand your existing modules instead of hallucinating new ones. This is exactly the direction I expect a lot of teams to go. Instead of asking a model, write me some random Terraform, you point it at your real modules and you say, compose with these building blocks. If you care about standardization and avoiding weird snowflake stacks, this kind of pattern is worth watching. Next, a small but very useful tool, Runs-On's EC2 instance family ranking. It is a page that ranks EC2 families by passmark CPU performance, split across x86 and ARM, and it lets you dig into detailed benchmarks and even pricing via their API. If you ever picked an instance type purely by habit, this is the antidote. Before you copy paste M5 large, again, you can check where M7G or M8A sit on the performance curve and what that means for your workloads. It is a nice way to bring a little data into those instance choice conversations without running your own benchmark suite. And the last lightning item, an SRE story from Airbnb. They published From Static Rate Limiting to Adaptive Traffic Management in Airbnb's Key Value Store. It is about their key value store muscle and how they evolve static QPS limits into a more adaptive system that looks at short-term latency relative to long-term baseline and adjusts limits dynamically. The interesting idea here is using ratios like current P95 over trailing P95 as a signal that the system is under stress, then having the rate limiter react before things really fall over. Even if you do not copy their exact design, it is a nice example of moving beyond fixed per customer limits into something that responds to real conditions. All right, let's close it with a human story. Nolan Lawson wrote a piece called The Fate of Small Open Source. It is about tiny libraries and tools and the stuff that might be a few hundred lines of code that still get millions of downloads and quietly sit at the bottom of everyone's dependency graph. He talks about one of his own packages that has been around for about a decade, still getting 5 million downloads per week, and how LLMs change the equation. If you can just ask a model to spit out a custom helper function, do you really need another dependency? And if people do keep using these tiny libraries, what does that mean for the one maintainer handling issues and security reports for free? I think this hits home for platform teams in two ways. First, look at your own tooling. Terraform providers, little CLI helpers, internal scripts, custom controllers. A lot of that probably rests on one or two small open source projects that someone wrote on nights and weekends. Terrascam being archived recently is a good reminder that tools you depend on can go away when the incentives for the maintainers shift. Second, we are starting to see companies say, why add a new dependency when an LLM can just generate the 5 lines of code we need? That might reduce supply chain risk in some places, but it also raises questions about how new utility libraries get created and maintained in the first place. So, what do you do with that? Practically, I would make a list of small critical dependencies in your platform. Things where if the repo went read only tomorrow, you would be in trouble. Ask what your plan B is. Could you fork it, vendor it, or replace it if needed? Maybe consider sponsoring a few of these maintainers. Even a small amount can make a difference and is a good signal to the rest of your org that this stuff matters. Think twice before outsourcing important functionality to a single tiny project without at least acknowledging the risk. And when you are tempted to say the AI can just generate this, maybe also think about whether that code will need to be maintained, audited, and shared across teams in the future. Sometimes the boring little libraries with tests and a maintainer is still the better choice. All right, that is it for this episode of Ship It Weekly. We walked through the AWS reInvent updates that actually matter for platform teams, from regional NAT gateways and Route 53 global resolver to ECS express mode, EKS capabilities, S3 vectors, 50 terabyte objects, Aurora dynamic masking, CodeCommit's return to GA, and IAM Policy Autopilot. We looked at Google's 130,000 node GKE cluster and used it as a lens on control plane scaling and cluster design at more normal sizes. We dug into the kill staging test in production argument and how to make that safe with feature flags and progressive delivery. In the lightning round, we talked about Terraform MCP servers for module aware AI, EC2 instance rankings that help you right size with data instead of vibes, and Airbnb's adaptive traffic management for their key value store. And we wrapped with Nolan Lawson's piece on the fate of small open source and what that means for all the tiny projects your platform silently leans on. I will put all of the links we talked about in the show notes. I am Brian. This is Ship It Weekly by Tellers Tech. Thanks for hanging out, and I'll see you in the next one.